So today we'll discuss about different types of space orbits. We know that orbit is a path in which the satellite revolves around the Earth. Or even we can also consider the path in which Earth revolving around the Sun. So the path in which the satellite is moving around the Earth, we call it as an orbit. And these orbits are divided into different categories. Among them, one of the category is that LEO. We call it as low Earth orbits. When we consider low Earth orbits, the distance of the orbit from the surface of the Earth is from 160 to 2000 kilometers. And mostly the satellites in these orbits revolve around the Earth within a time duration of 1.5 to 2 hours. And these are very close to the Earth. So when a satellite is very close to the Earth, it has low signal delay. And satellites move fast relative to the Earth. As they are very close, they move very fast relative to the Earth and requires less power for transmission. So for transmission of the data, it requires low power as it is very close to the Earth's surface. And mostly low Earth orbits are used for Earth observation, remote sensing, scientific research, satellite phones, and space stations. So these are some of the applications of low Earth orbits. And similarly, we have another category of orbits which we call them as medium Earth orbits, or MEO in a short we can call it as. And the altitude of these satellites is from 2000 kilometers to 35,786 kilometers. And the duration of the satellite to revolve around the Earth is from 2 to 24 hours. And these orbits are, they have the moderate signal delay used for navigation systems, wide coverage than LEO, because as the LEO satellites are very close to the Earth, the coverage area is less. But as the medium Earth orbit satellites are little far away from the surface of the Earth, so as the altitude increases, even the coverage area also increases. In that way, medium Earth orbits have more coverage than the low Earth orbits. And another category of the orbits is the geostationary orbit. So we call an orbit as geostationary orbit when the satellite revolves around the Earth at the same speed as that of the Earth. And the satellite appears to be stationary with respect to the observer always, because as it moves with the same speed of the Earth, whenever we see the satellite, it will be at the same position, because both the Earth as well as the satellite move with the same speeds. And these orbits, so a satellite will be in geostationary when the radius of the orbit from the surface of the Earth, or the distance of the satellite from the surface of the Earth is about 35,786 kilometers. And the duration of the satellite is exactly equal to the duration of Earth's one rotation. That is one sidereal day mostly, 23 hours 56 minutes 4 seconds. And the key characteristics of these satellites, if you see, these appears to be stationary in the sky always, covers very large area. But as they are very far from the Earth's surface, signal delay will be more. And ground antenna can remain fixed because there is no need of changing the position of the antenna, because with respect to the position of the antenna, the satellite will be always in a stationary position as it moves with the same speed of the Earth. And mostly these satellites are used for communication, broadcasting, TV, radio broadcasting, weather monitoring. So these are some of the applications which we have in geostationary orbits. And another category of the orbits we have, we call it as geosynchronous orbit. So geosynchronous orbits what is the difference between geostationary and geosynchronous means? Geostationary is always, the orbit is always parallel to the equator, but geosynchronous is not parallel to the equator, but it exactly revolves around the earth equal to one sidereal day. So even these satellites are also at the radius of 35,786 kilometers. So that is the difference between geosynchronous and geostationary. Geosynchronous will not appear to be stationary always with respect to the observer, because they move in an inclined orbits. That's the reason why we cannot have the stationary position of the satellite, but the radius of it is same, as well as the time which it takes to revolve around the earth is also same as the geostationary orbit, but not parallel to the equator. And another kind of orbits we have is polar orbits. If we have a satellite which covers the north pole and south pole, then we call it as a polar orbit. That means the satellite will be moving vertically. It doesn't move parallel to the equator, but perpendicular to the equator it moves, and the altitude of the satellite is about 200 to 1000 kilometers. So mostly in order to observe the earth's surface, remote sensing, mapping, weather monitoring, we'll be using these orbit satellites, which we call them as a polar orbit. These are perpendicular to the equator. And we have another type of orbits also, one which we call it as highly elliptical orbit. So depending upon the eccentricity, if the eccentricity is high, then we categorize those orbits to be highly elliptical orbit. So these, if you want to cover some specific region, we can design this orbit so that it comes very close to the earth during that position, and again it goes very far away from the earth's surface. In the another end, if you see, it goes very far from the earth's surface. If we have such way, then we can call it as a highly elliptical orbits. So depending upon the eccentricity, if the eccentricity is high, then we call it to be highly elliptical orbit. And another category of the orbits we have, which we call it as sun synchronous orbit. These will be always synchronous to the position of the sun, and the altitude of them is about 600 to 800 kilometers. It is a special type of polar orbit, crosses given location at the same local solar time. That's the main function of sun synchronous orbit, that is, it crosses a given location at the same local solar time. And these are mostly used for remote sensing, environmental monitoring, land mapping, and disaster management. Even we have another type of orbits which we call as prograde orbit and retrograde orbit. A prograde orbit is an orbit if the satellite moves in the direction of the earth, then we call it as a prograde orbit. If the satellite moves opposite to the direction of the earth, then we call it as a retrograde orbit. So these are, we have different types of orbits used for satellite.